In this video, you are going to learn about two other methods to solve the system of linear equation, which is inverse matrix method, and the second one is Cramer's rule. We are going to learn about the other two methods which involve the matrix method. So the first method is using the inverse matrix method. So given from the system of linear equation, we can write this system of linear equation in terms of AX equals to B, where A is the coefficients matrix, where it is the coefficients of all variables in the system of linear equations, and X is the matrix that contains all the variables of x1, x2 up until xn, equals to B, where B is the matrix that contains all the elements of constant B. So using the inverse matrix method, if inverse matrix A exists, then we can find the variable of x1 up until xn, which is equal to the inverse matrix of A times with matrix B. Find this inverse matrix of A. So you can refer the previous note from 5.5, how to find the inverse matrix of A. There are two methods. The first one is involve the ERO method, where this is also can call as using Gauss-Jordan method. And another method used is using adjoint method. So these two methods are used to find the inverse matrix of A. So after we get the inverse matrix of A, then we multiply with matrix B, then we can find the variable of x1, x2 up until xn. Now let us try the first example. Solve the system of linear equations by using the method of inverse matrix. Given the system of linear equation is a 2 by 2, which is 5x plus 3y equals 2, and 2x plus y equals to negative 6. So here, what we can do first is that we need to rewrite this system of linear equations into matrix form. So the matrix form will be in terms of AX equals to B, where our A is the coefficients of the variable x and y. So here we have 5 and 3, 2 and 1, and our matrix X is x and y. Because the variables from the system of linear equation is x and y. But if the variables given in the system of linear equation is x1 and x2, then you have to write the X matrix should be x1 and y1. Sorry, x1 and x2. So here this will be equals to B, where B is given as 2, negative 6. So here what we want to do is that we want to find the value of the variable of x, where we can find this by taking the inverse matrix of A multiplied by B. So here our A is equals to 5, 3, 2, 1. So I'm going to show you using the elementary row operations or using the Gauss-Jordan method. And you can try to solve using the adjoint method and compare with the solution I get from this ERO method. So using the ERO method, what you need to do is that you have to write the matrix in terms of augmented matrix of matrix A and identity matrix. So our matrix A is given as 5, 3, 2, and 1. Therefore, our identity matrix will be a 2 by 2 matrix since our matrix A is 2 by 2 matrix. So this will be 1, 0, 0, 1. So we want to get our final solution should be in terms of I augment with B, where our B is the inverse matrix of A. So here, what we need to do is we have to make sure this element should be 0. So in order to do that, we have to multiply our R2 should be equals to 5 R2 minus with 2 times with R1. We rewrite the row 1, 5, 3, 1, 0, and our second row will be 10 minus 10, which is 0, and then 5 minus 2 times 3 is negative 1, 0 minus 2 times 1 will be negative 2, and the last one will be 5 minus 0. Now the next step is that we have to make sure that this element should be 0. So in order to do that, our row 1 should be equals to R1 plus 3 R2. So here will be 5 plus 0, which is 5, and then 3 minus 3 will be 0, 1, and then for the third column, 1 plus 3 times negative 2, so here we will have negative 5, and the last one will be 0 plus 3 times 5, which is 15. And the second row, which is in this term. Okay, now the next step is that we have to make sure that the diagonal of this matrix should be 1. So in order to do that, our first row must be divided by 5. Then we will have 1, 0, negative 1, 3, and our second row should be multiplied with negative of R2. So here we have 0, 1, 2, and negative 5. So now we get the matrix in terms of the augmented matrix, which is identity augment with another new matrix, where this new matrix is equals to the inverse matrix of A, where the inverse matrix of A is equals to negative 1, 3, 2, and negative 5. So now we have solved this inverse matrix. What we need to do is just we substitute into this formula in order to obtain the value of x and y. So our x and y will be equals to matrix inverse matrix of A, which is negative 1, 3, 2, negative 5, multiply with B, which is 2, negative 6. So I just rewrite the previous solution into a new slide. So the next step is that multiply these two matrices. So we have negative 1 times 2 plus 3 times negative 6 and 2 times 2 plus negative 5 times with negative 6. Then the simplify this, we get negative 2 minus 18 and 4 plus 30, where this is equals to negative 20 and 34. Therefore, we have solved this system of linear equations by using the inverse matrix method, where our x value is equals to negative 20 and our y is equals to 34. Now let us try the second example. Solve the system of linear equations using the method of inverse matrix. So for the first step is that we have to transform the system of linear equations into the matrix form, which is in terms of ax equals to b, where our a is equals to 1, 3, 3, 1, 4, 3, and 1, 3, 4. And our x, so the variables involved here is x, y, and z. And the B matrix is the constant on the right hand side, so it will be negative 1, 2, and 3. So from this, we can obtain the variable of x, which is x, y, z, by taking the inverse matrix of A multiplied with B. So in order to find the inverse matrix of A, what we need to do, we can use adjoint method. Or the second one is using Gauss-Jordan elimination method, where this we have to find the augmented matrix of A augmented with identity matrix and transform the matrix A into the identity matrix, and we obtain the inverse of matrix, which is in terms of matrix B. So for this solution for question number 2, I'm going to show you how to use the adjoint method. First, to find the inverse matrix of A, we use the adjoint method. So the first step in the adjoint method is we find the determinant of A. So using the row operation, first row operation, so our determinant of A will be equals to 1 times with the magnitude of matrix 4, 3, 3, 4. And don't forget the second sign should be minus 3. So we eliminate the first row and the second column. So the matrix will be 1, 3, 1, 4. Plus with the third element, third column 1 first row. So this will be plus 3 times with the determinant of matrix 1, 4, 1, 3. So here the determinant of A will be 1 times 4 times 4, which is 16, minus with 3 times 3, which is 9, minus 3 times with 4 minus 3, plus 3 times with 3 minus 4. So here we have 7 minus 3 times 1 plus 3 times negative 1. So this will be 7 minus 6, which is 1. So the determinant will be equals to 1. So it means that since the determinant is not equals to 0, it means that the inverse matrix of A, so it means that the matrix A has inverse matrix of A. The second step is to find the minor matrix of IJ. So for the first one is we find the determinant of M11, where to find the minor matrix for M11 is that we have to remove the first row and the first column. So what is left is that the determinant of this matrix 4, 3, 3 and 4. So here the determinant will be 4 times 4, which is 16, minus 3 times 3, which is 9. Then we proceed with the next M12, where the matrix of M12 is removing the first row and the second column. So here we have 1, 3, 1, 4. So the determinant of this will be 1 times 4 minus 1 times 3, which is equals to 1. And the last one is finding the determinant of M13. So this will be removing the first row, third column, and the matrix will be 1, 4, 1, 3. Then we find the determinant of this matrix. So here it is 1 times 3, which is 3 minus 4, which is equals to negative 1. Then we proceed with the next row, which is M21. For M21 means that we remove the second row and the first column. So the matrix will be 3, 3, 3, 4. Finding the determinant will be 12 minus 3 times 3 is 9. This one is equals to 3. And then M22 will be equals to remove the second row and second column. Here we have 1, 3, 1, 4. This will be equals to 4 minus 3. And the last one will be minor matrix M23, which is equals to removing the second row, third column. So here we have 1, 3, 1, 3. So this will be equals to 0. So now the next step is, the last one is finding the third row, first column. So we remove the third row, first column. So we will remove the third column, third row and first column. Our matrix will be 3, 3, 4, 3. This will be 9 minus 12. This equals to negative 3. And then find the minor matrix for M32. So for this case, we remove the third row and the second column. This will be 1, 3, 1, 3. And finding the determinant will be 3 minus 3, which is equals to 0. And the last one is find the minor matrix of 3, 3. So here we have removed the third row and third column. So our matrix will be 1, 3, 1, 4. 4 minus 3, which is equals to 1. So we can rewrite this, our Mij, which is equals to, our M11 is equals to 7, M12 is 1, M13 is negative 1, M21 is 3, M22 1, M23 0, M31 is negative 3, M32 is 0, and the last one is M33, which is 1. Once we get the minor matrix of Mij, the next step is to find the cofactor Cij, where the formula for Cij is equals to -1 to the power of I plus j times with matrix or determinant of Mij. So if we assign this sign matrix, our Cij should be in terms of positive, negative, positive. And then for second row, start with negative, positive, negative. And for the third row, should be start with positive, negative, positive. So our Cij, and we multiply with the sign here with Mij. So for the first row, this should be 7, -1, -1. 7, -1, -1. And for the second row, this sign we multiply with this. So here we have -3. And then for the second row, second column, this will be plus times with 1. So here we have 1. And then for the second row, third column, so this will be remain as 0. And then for the third row, first column, this should be +1 times with -3. And then the second column, third row will be 0. And the last one will be 1. Okay, now we have found the cofactor. The next step is that we have to find the adjoint matrix of A, where to find the adjoint matrix of A, it is actually equals to the transpose of Cij. So from here, our transpose of Cij is equals to, so transposing means that we change the row with the column. So for the first row, first column, 7 here is remain as first row, first column. And then for the first row, second column will be first row, second column will be second row, first column. And our first row, third column will be third row, first column. Same goes with the second row. So here will be -3, 1, and 0. And the last row will be changed into the column. So -3, 0, and 1. So now we have solved the adjoint matrix of A. Then finally, we can find the inverse matrix of A by taking 1 over the determinant of A multiplied with adjoint A. So based on the previous calculation for the determinant, where our A, determinant of A, is equals to 1. So here 1 over 1 will be 1 times with adjoint A, which is equals to this matrix. So this will be our inverse matrix. Okay, now we have solved this inverse matrix. We still not solve the system of linear equations. The next step is that we have to find vector x equals to the inverse matrix of A times with matrix B. So now what we need to do is to substitute all the values of inverse matrix of A and matrix B. So here we have 7, -3, -3, -1, 1, 0, -1, 0, 1 times with matrix B, which is -1, 2, and 3, where our X matrix is given as X, Y, and Z. Then multiply this. So what we need to do is multiply matrix A with B. So here we have 7 times -1 plus -3 times 2 plus -3 times 3. And for the second row, -1 times -1 plus 1 times 2 plus 0 times 3. And the last row will be -1 times -1 plus 0 times 2 plus 1 times 3, where this will be equals to and then for the second row and the third row will be equals to -22, 3, and 4. So we can conclude that the value of x is equals to -22, y is equals to 3, and z is equals to 4. Now we have solved the system of linear equations. So this is the solution 2, or an alternative solution, where this solution I show you how to find the inverse matrix using the elementary row operations. You can check your solutions with my solution here. The last method used to solve the system of linear equations is using Cramer's rule. Given the system of linear equation is given as this, then we write the system of linear equations in terms of Ax equals to b, where A is the coefficients of variable x1, x2, and xn, or we call it as coefficient matrix. And our x is the variable of x1 up until xn, and b is matrix of constant b1 up until bn. So from here, if the determinant of matrix A is not equals to 0, it means that we can find the inverse matrix, or the inverse matrix of A exists. Then the solution for system of linear equation can be obtained using the Cramer's rule, where the formula for Cramer's rule is given as xi equals to the determinant of matrix AI divided by determinant of matrix A, where matrix AI is a matrix obtained by replacing the ith column of A by vector B. So if we have three variables, which is x1, x2, and x3, so we need to find the determinant of A1, A2, and A3. And if we have our matrix, or we have variable up until 2, which is contains x and y, so we need to find the matrix A1 and A2 to find this value of s and y. So let us try example so that you can find how to use the Cramer's rule to solve the system of linear equations. Given the question asks you to solve the system of linear equations using Cramer's rule. Given the system of linear equations is written in this form. For the first step is we transform the system of linear equations into matrix form, where it is in terms of A, x equals to B. So our matrix of A is equals to 2, negative 1, 1, 1, 3, negative 4, 3, 7, negative 2. And our x will be 3 variables, which is x1, x2, and x3. And our matrix B will be 3, negative 5, 11. The next step is find the determinant of matrix A. So to find the determinant of matrix A will be equals to 2 times width, 3 times negative 4, 7, negative 2. And then for the second part should be in terms of negative. And then multiply with A12, which is negative 1. So we remove the first row, second column, and the matrix will be 1, negative 4, 3, and negative 2. And the last one, the sign should be positive. 1 times with matrix. Remove the first row, third column. So here will be 1, 3, 3, and 7. Then we find the determinant of this matrix. Negative 6 minus negative 28 plus negative 2 minus with 12 and the last one will be 7 minus with 9. So the determinant of matrix A will be equals to 52. Since our system of linear equations contains 3 variables, which is x1, x2, and x3, so our aim is to find x1, x2, and x3. So using the Cramer's rule formula, where what we need to do to find the x1 is that you have to find the determinant of matrix A1 divided by determinant of A, and then the determinant of A2 divided by the determinant of matrix A, and the last one is to find the determinant of A3 divided by the determinant of A to find the variable for x3. And this is the formula to find the variable of x2, and the last one, this is the formula to find the variable of x1. So first we try to solve the variable of x1. So I just rewrite all the important matrix here. So in order to find the matrix A1 is, so meaning that for A1 is the matrix. So A1 is a matrix that is obtained by replacing the first column of A by matrix B. So here, our first column of A will be replaced with column in B. So now our A1 is equals to 3, negative 5, 11, and the remaining column is the same as it is. Negative 1, 3, 7, 1, negative 4, negative 2. So this is the matrix of A1. So from here we can find the determinant of A1, where this will be equals to 3 times with 3 minus 4, 7, and negative 2 minus, so don't forget the sign for the second part where it should be negative, times with negative 1 multiply with the matrix of negative 5, negative 4, 11, negative 2, and the last one will be plus 1 times with negative 5, 3, 11, and 7. So calculating all this, so here will be equals to 3 times with negative 6 plus 28 plus 10 plus 44, and the last one is plus negative 35 minus 33. So this will be equals to 52. So now we have obtained the determinant of matrix A1. So what we need to do next is find the x1, where x1 is the determinant of A1, divide by the determinant of A, where the determinant of A1 is equals to 52, divide by 52. So here we have our value of x1 is equals to 1. So the next step is to find x2, where the formula of x2 is equals to the determinant of matrix A2 divided by the determinant of matrix A. So for this case, A2 is a matrix that is obtained by replacing the second column of A by vector B. So here, our A2 will be equals to 2, 1, 3, and we replace the second column here with matrix B. So here we have 3, negative 5, 11, 1, negative 4, negative 2. Then we find the determinant of A2. And for the second part should be negative sign, 3 times with 1 minus 4, 3 minus 2, and the last part should be positive 1 times with 1, negative 5, 3, and 11. So here we have 10 plus 44 minus 3 times with negative 2 plus 12, and the last one will be 11 minus with negative 15, so positive 15. So this will be equals to 104. So now we can solve our x2 will be equals to the determinant of A2 divided by the determinant of A, where this will be equals to 104 divided by A, which is 52, and the final answer will be equals to 2. So our x2 will be equals to 2. So the last step is to find x3, where the formula for x3 using the Cramer's rule is the determinant of A3 divided by the determinant of A, where A3 is a matrix that is obtained by replacing the third column of A with B. So now our A3 is equals to, so we replace the third column of A with B. So our A3 will be in terms of this matrix. So next is finding the determinant of A3. So the first one will be 2 times with 3, negative 5, 7, 11, and then minus with negative 1 times with 1, negative 5, 3, 11, and the last one is plus 3 times with 1, 3, 3, 7. So solving this, we have 2 times 33 plus 35 plus 11 plus 15, and then plus 3 times with 7 minus 9. The answer will be 156. So now our x3 is equals to the determinant of matrix A3 divided by matrix A, determinant of matrix A. So here we have x3, which is 156 divided by 52. So our x3 will be equals to 3. So from all the calculations, we can conclude that our value of x1, which is equals to 1, x2 is equals to 2, and our x3 is equals to 3. So that's all for Cramer's rule. You can pause this video and try to solve the following system of linear equations using Cramer's rule, and try to find the answer of your solution, which is x1 equals to 2, x2 is equals to 1, and x3 is equals to negative 2. So in conclusion, the Cramer's rule can be used if determinant of A is not equals to 0. So it means that the inverse of matrix of A exists. And the second one is A is a n by n matrix, which means that it is a square matrix. If A is not a square matrix, this rule cannot be applied, or we cannot use the Cramer's rule. Means that we have to use Gauss elimination or Gauss-Jordan elimination for this type of problem.